You are welcome to today's lesson. In our previous discussion, we discussed the nth term of an arithmetic sequence. In today's lesson, we are looking at the sum of a linear sequence. How do we determine the sum of a linear sequence? Let's consider any linear sequence of the form 2, 4, 6, 8, 10, 12 in that order. Now we can find the sum of the first two terms. The first two terms talks about the first two numbers in the sequence. And so that is S subscript 2, which is S2 equals 2 plus 4. The 2 and 4 represent the first two terms in the sequence. So when we have to add them up, it will produce the result 6. Considering the same sequence, we can find the sum of the first three terms. First three terms talks about the first three numbers in the sequence, and that is given by S subscript 3, which is S3 equals 2 plus 4 plus 6. And that will produce the result 12. Using the same sequence, we can also find the sum of the first four terms, and that is given by S subscript 4 or S4 equals 2 plus 4 plus 6 plus 8, and that will produce the result 20. Now let's take note that as the number of terms increase, it becomes very difficult finding the sum of the sequence as we have done already. For instance, if I have the sequence 2, 4, 6, 8, 10, 12, 14, and I want to find the sum of the first 6 terms, it means I would have to add 2 plus 4 plus 6 plus 8 plus 10 plus 12, because these are the first 6 terms. And this is what we mean by as the terms increase, it becomes very difficult to add them up to find the sum of the sequence. Now we can therefore adopt a formula that will help us to determine the sum of the sequence without necessarily writing down all the terms in the sequence. In other words, we can use a formula to help us find the sum of any given sequence without necessarily writing or adding all the numbers together. Now the sum, which is also represented as S subscript n or Sn, of the first n terms of a linear sequence is given by Sn equals n out of 2 or n over 2 multiplying 2a plus n minus 1 all multiplied by d. Don't worry if the formula looks cumbersome. We can simplify it further. When I have the formula for the sum of a linear sequence, which is given by S subscript n or Sn equals n out of 2 all multiplied by 2a plus n minus 1 all multiplied by d. This formula can be simplified as S subscript n equals n out of 2 bracket open a plus n minus 1 all multiplied by d. In other words, 2a can be expanded as a plus a. Remember, from our concept of algebraic expression, a plus a will produce 2a. And so we can expand 2a to give us a plus a. And remember that this part of the formula represents something we already know. And that is the formula for finding the nth term of an arithmetic progression, which is the last term of any arithmetic progression. So a plus n minus 1 all multiplied by d, remember, is the last term or the nth term of an arithmetic progression. So this formula for the sum of a linear sequence can be simplified to give S subscript n, which is Sn, equals n out of 2 all multiplied by a plus l, where we know that the n represents the number of terms, the a represents the first term, and the l represents the last term. Let's look at an example. In this example, we have to find the sum of the numbers 5, 8, 11, 14, 17, 20, 23, 26, 29, 32. And so in this case, we have to add all the numbers together. In our solution, remember that to find the sum of any linear sequence, it is given by S subscript n equals n out of 2 multiplied by a plus l. And we know that based on the question, the number of terms we have is 10. So when we have to count all the numbers given from 5 up to 32, you can see that the numbers are 10. And A represents the first number, which is 5, and L represents the last term, which is 32. And so when we are to substitute it into our formula, we'll be having S subscript 10, which is the sum of 10 linear sequence, is given by 10 out of 2, all multiplied by 5 plus 32. And that will produce the answer 185. So this implies that when we are to sum all the 10 numbers in the sequence up, it will give us 185. Let's look at an example. In this example, we have to find the sum of the first 15 terms of the sequence 2, 5, 8. So how do we get the sum of the first 15 terms? In our solution, we are going to apply the formula for finding the sum of any linear sequence, which is given by S subscript n, or Sn equals n out of 2 multiplied by A plus L. And so in this question, the number of terms we are looking for is 15. That is the sum of the first 15 terms. So n is 15, and the first term, which is represented as A, is 2. But there is one thing missing. That is the last term. If you look at the sequence given in the question, we were only given 2, 5, 8, and the rest of the sequence was not given. So it means the last term is missing. So before we can find the sum of the first 15 terms, we need to look out for the last term. And we know that the last term is given by A plus n minus 1 all multiplied by D. So to get the last term, I need the value of A, which is the first term. I need n, which is the number of terms, and D, which is the common difference. A, which is the first term, is given as 2. N, which is the number of terms, that is, we have to find the first 15 terms. So n represents 15. D also represents the common difference, which is 3. In other words, when I subtract 2, which is the first term, from the second term 5, it will produce 3. If I also subtract the second term 5 from the third term 8, it will also produce a common difference of 3. So meaning D equals 3. When we are to substitute our values into the formula, L becomes 2 plus 15 minus 1 all multiplied by 3. And when we are to further simplify, L becomes 2 plus 14 all multiplied by 3. And that will produce our last term to be 44. So in this case, the last term for this linear sequence is 44. Now we can find the sum of the first 15 terms in the linear sequence, since the last term is known. And so n is 15, that is the first 15 terms. A is the first term, which is 2, and the last term is now known to be 44. So when we are to substitute, the sum of the first 15 terms is given by 15 out of 2, all multiplied by 2 plus 44. We can further simplify this to give us 15 out of 2 multiplied by 46. And that will produce our final answer to be 345, meaning that when we are to sum the first 15 terms in the linear sequence, we are going to produce 345. Let's look at our next example. In this example, we are to find the sum of all positive odd numbers that are less than 200. To answer our question, we need to list all positive odd numbers that are less than 200. And that will start with 1 and end with 199. And so to find the sum of all positive odd numbers less than 200, we apply the formula for finding the sum of any linear sequence, which is given by S subscript n equals n out of 2 all multiplied by A plus L. In this question, the number of terms is not known. In other words, how many terms do we have from 1 up to 199? 1, 3, 5, 7. If we are to count all the terms, how many are they? We don't know. And the first term, which is A, is 1. And the last term is represented as 199. And so before we can find the sum of all positive odd numbers less than 200, we need to know the number of terms that lies from 1 up to 199. And to do that, we are going to use the formula for finding the nth term of any arithmetic sequence, which is given by L equals A plus n minus 1 all multiplied by D. In this case, we are going to substitute the values for L, A, and D. And so the L, which is the last term, is noted to be 199. The first term in the sequence is 1, and the common difference, that is, if I subtract their differences, I'm going to be getting D to be 2. When we are to substitute, we are going to have 199 equals 1 plus n minus 1 all multiplied by 2. And so in this case, the number 2 is going to multiply everything within the bracket. Remember that we are finding the number of terms. And so when we are to multiply 2 by the numbers within the bracket, we are going to produce 199 equals 1 plus 2 multiplying n will give us 2n, and also 2 multiplying -1 will produce -2. We can also continue our solution by grouping like terms. And some of the like terms we can identify are 1 and -2. Grouping them together will give us 199 equals 1 minus 2 plus 2n. And that will become 199 equals -1 plus 2n. Also, we can group other like terms like -1 and 199. And so moving -1 to the left will become a positive number because it is crossing the equal to sign. And that will become 199 plus 1 equals 2n. And that will give us 200 equals 2n, which can also be written as 2n equals 200. So to find the value of n, we divide both sides by 2. When we divide through by 2, n becomes 100. In other words, when we are to count all the terms from 1 up to 199, that will be 100 terms. So now, since the number of terms is known, we can go ahead and find the sum of all positive odd numbers that are less than 200. N becomes 100. The A, which is the first term, is 1, and the last term is noted to be 199. So when we are to substitute, we are going to have the sum of the 100 terms to be 100 out of 2, all multiplied by 1 plus 199. And that will give us 100 out of 2 multiplied by 200, which also produce 50 multiplied by 200. So it means that when we are to sum all the 100 terms, which is the sum of all positive odd numbers from 1 up to 199, that will give us 10,000. In other words, the sum of all positive odd numbers which are less than 200 is 10,000. Now let's take a look at our assignment for the lesson. In our assignment, we have to find the sum of the first 18 terms of the sequence 258. In our second question, we are also to find the sum of the numbers 4, 9, 14, 19, 24, 29, 34, 39. And our last question, we have to find the sum of all positive even numbers that are less than 201. Thanks for watching and see you in the next lesson.